Okay, in this video, we are going to determine if a function will be an even, odd, or neither function. And these are the three problems that we will solve together. But before we do that, it's important to know, how can we even determine if something's going to be even, odd, or neither? And with even and odd, there's two ways. I'm going to show you both ways. With an even function, if f parentheses negative x is equal to f of x, then it's an even function. And you have symmetry about the y-axis. So this right here is one example. Now this is the form that I like the best. It says expanded form, each power is even, and a constant has a zero power, and zero is considered even. Again, we're going to see both methods. But in this example, so 4 is even, 2 is even, a constant has zero power, and a zero is even. Because of that, this is going to be an even function. An odd function, f parentheses negative x, is equal to negative f parentheses x. And you have symmetry about the origin, so you notice here and here, they got flipped. X and y got flipped. And for this one, expanded form, each power is odd. So this one, power is 3, 3 is odd. This one, x raised to 1, the power is 1, and 1 is odd. Now, a neither function has a combination of some even terms, some odd terms. And so let's begin, and again, we'll use both methods. So let's call this method 1. So we have 5x squared minus 3. So we see a 2, and the power is even because 2 is even. This has no power, but if it helps you, you can write x raised to 0. And 0 is even. Because x raised to 0 is actually just 1. So that's why this has a 0 power. The power is 0. And 0 is considered even. So because both of these terms are even, it's going to be an even function. So that's one method of doing it. And now I'll show you another method. The other method for an even function, this must be true. F parentheses negative x is equal to f of x. And we already have f of x. This is f of x. So we just need to figure out what is f parentheses negative x going to give us. So let's try this out. So we have 5 parentheses. Instead of putting an x, you're going to put a negative x. Close parentheses squared minus 3. And negative x raised to 2 is negative x times negative x, which is positive x squared. So we get 5x squared minus 3. And we see it is in fact identical. Because it's identical, it's an even function. So we just proved that this function right here is an even function using two methods. Okay, this will be the second one. Again, we'll use both methods. So let's do method 1. This is odd. Again, we're just looking at the power. This one, x, it's x raised to 1. And we know 1 is odd. Because both of these terms, all of the terms are odd, it's going to be an odd function. Again, that's really all you have to do with this method. But I'm also going to show you the second method. And for an odd function, the way we have to check is f parentheses negative x is going to equal negative f parentheses x. So we got to try both of them. So let's try the first one. 2 parentheses negative x raised to 3 minus 4 parentheses negative x. And what is that going to give us? So negative x times negative x times negative x. You have 3 of them. So you'll get a negative 2x cubed. A negative 4 times a negative x is a positive 4x. And now we had to try this version. So this version says negative parentheses copy. 2x cubed minus 4x. And let's see what this gives us. We got to distribute this negative to both pieces. So we'll get a negative 2x cubed. A negative 4x is a positive 4x. And so we do see that it is in fact identical. Because it's identical, it's an odd function. Okay, last one. So we see this 2 tells us this piece is even. X raised to 1. So 1 is odd. So automatically we can stop here. And we know it's going to be a neither. Because it has a combination of even and odd. So I guess we have to do two things to prove whether it's even or odd if you want to use the second method. So again, if f of x is equal to f parentheses negative x, it's going to be even function. Or I'll just put even. And if you have f parentheses negative x. And if that's equal to negative f parentheses x, it's going to be odd. So I guess we have to try both of them. So I have f of x, so I guess I can get this one pretty easily. So f parentheses negative x, let's try it. 3 parentheses negative x squared minus 4 parentheses negative x plus 5. So I'm going to get negative x times negative x is positive x squared, so 3x squared. Negative 4 times negative x is positive 4x, and that's a positive 5. And let's see, does it match? So it does not match because this piece is a negative and this piece is a positive. So it does not match. Again, think about this. Using the first method, we even showed it was odd. And both of these pieces are even. So yeah, that makes sense that this piece and this piece were the same. But this piece, the odd piece, is not going to match. So that does not work. So now we can try this one piece just to see if it's odd or not. So we can say negative f parentheses x is equal to, so we had 3x squared minus 4x plus 5. So we're going to copy that down. Negative parentheses 3x squared minus 4x plus 5. And let's see, what do we get? So again, we have to distribute this negative to all three pieces. So we're going to get a negative 3x squared. A negative negative gives you a positive 4x. And a negative positive gives you a negative 5. And again, you notice this piece does not match this piece. So it's also not an odd function. And that's pretty much it to determine if a function will be even, odd, or neither.